Hello guys, good morning. Welcome to, welcome to the session today. Hope you all can able to hear me. Okay, let us start the session. So if you remember, last time we have seen, so far what we have seen, let me try to tell you. So far we have seen what is a cloud storage, cloud SQL, sorry, the BigQuery. So these are the three things that we have seen so far. Today we are starting a one more topic, that is DataProc. So it's a Spark and Hadoop environment. So we can see here, this is our object storage service. This is our OLTP, online transactional processing. This is our OLAP, online analytical processing or data warehouse. And this is what we are going to learn is data processing service. Okay, it's a data processing service. So today we are going to start with the DataProc. So let us try to understand what is a data processing and what we are going to do here and how, which language we are going to learn. All of those things, let us try to learn one by one. Okay. And before this one, maybe we're going to start the coding class maybe from tomorrow. But before that, I want you guys to spend some time and try to understand few things. I think most of the people are already aware of SQL concepts. That's a reason I'm not focusing on. But I want you guys to focus on these things maybe today, by tomorrow, so that because I'm going to talk about C. These are the basic concepts of Python. You can go to any YouTube or you can go to some online channels. So any channel you can go, just to focus on these things like what is a data type, integer, string, float, boolean, array, list, tuple, dictionary. Just try to understand how it looks like. That's it. And after that, what is a variable? What is operators? And formatting. This is not much required, but just if you can focus. And the conditions like if else condition, if else conditions, while conditions, for loops. Okay. Just understand these basic concepts. What is a function? How to define a function? What is a map? What is the difference between map and reduce? So whenever you get time, just to focus on these things by Python basics, basic concepts. Just try to understand what is this thing and how it looks like. That's it. You need not to go into very detail and try to understand. Just to go to the data type. What is an integer? How it looks like? What is a list? How it looks like? What is a tuple? How it looks like? What is a dictionary? How it looks like? That's it. What are the operators? Okay, arithmetic operators, plus, minus, addition, subtraction, all of those things, modular. And what is the condition? What is if condition? What is if else condition? How the if condition will be used in Python? How the if else condition will be used in Python? How to define a function? What is a function? How to define a function? What is a loop? How to use for loop and how to use while loop? That's it. Basic concepts. Focus on these things, guys. I'm telling you. You have it here in the basic concepts, prerequisite. Okay, just you can go to the basics one. You can able to look at these things. Okay, yeah. Back to the session. So first, let me gonna give you a small idea before we are entering into the data prop. I want you guys to think about it. So as a data engineer, we have many challenges. Let us try to understand how these challenges were fixed by our Hadoop and Spark environment. Let us try to understand. Okay. First thing, sir, assume that you wanted to buy a laptop. Okay, you are a person, you wanted to buy one laptop. Okay, so what do? You usually go to one platform, maybe Amazon. Likewise, you go to one more platform, maybe eBay or some Flipkart. Okay, so you will go to different platforms looking for different options, and what you will do, the best features where it is available with a cheap price, you will be looking for that thing, and the best discount, all of those things you will be looking at the features, specifications, and the discount. All of those things you will be looking at. Maybe you will go to Amazon, you will go to Flipkart and eBay. Okay, you will go to these platforms and you are looking for a different options, and that in Amazon you couldn't buy any features. In Flipkart also you wouldn't buy any features. Okay, in eBay also you didn't find a best laptop within a cheap price, but there were few options that you liked it in Amazon as well as Flipkart. Okay, and out of these things you thought like a Flipkart is providing you the best benefits, so that you bought your laptop here. Finally, you bought your laptop here. Okay, so you have done some kind of analysis on the Amazon. Okay, and you have done some kind of analysis on the Flipkart, you have done some kind of analysis on the eBay as well. But the thing happened is that but the thing happened is that you couldn't find the best feature laptop in the Amazon, but you have found a laptop in the Flipkart. See, whenever you have done you have done some kind of a transaction, right? So this transaction will be added to the OLTP, something like Cloud SQL, MySQL. Okay, so what they do, if they wanted to do some kind of analysis, they will move the entire OLTP data to the OLAP. Okay, after 6 months or after this one, entire data will be stored in the OLAP only, so that now the data engineers will analyze this data. Data engineers will analyze this data and they will be able to come up with some kind of insights, so that that will be useful for the business decision making. Okay, so this is how when a person buy a laptop, so all the entire details will be added to the OLTP, and the data from the OLTP will be moved to the OLAP. OLAP data will be used for the analysis and processing purpose, and that will be used for the business decision making purpose. Okay, so this is what happens. But in terms of a Flipkart, it is good, sir. Okay, in terms of a Flipkart, it is good because this guy has bought a laptop here. So he has done kind of some transaction here. So the transactional details is added to the OLTP. But the problem with the Amazon eBay, if you look at it, the problem with the Amazon and eBay, what is the problem here, sir, is that so one guy has done some kind of a research in the Amazon for buying a or for looking at different options in the laptop section, but he didn't buy it. Same goes for the eBay also. One guy has done many research and looked for a different options, but he didn't buy any laptop. So what will happen, sir? What will happen is that so now Amazon wanted to understand the customer behavior. Amazon or eBay wanted to understand the customer behavior, because some people are looking for a different options, but they are not buying it. They are going to the some other platform and they may be buying there. They may be buying there. So what is the reason that they are not buying out here? Why they are not placing an order here? It's because it could be a reason that the way that they are showing the product is wrong. It could be a reason that the price of the product is high here. It could be a reason that the discount that they are providing is more on the product in other platforms. It could be a reason that the Amazon may not be able to provide the proper description for this product. So there can be many reasons. But who will tell us which reason is for this one? Who will tell us that which reason it is for? No one will be able to tell it. But Amazon wanted to know that reason, or eBay wanted to know that reason. Okay? But what they have? Do they have any information now? Flipkart has its own information because they have done a transaction. But does Amazon and eBay has any information now? Can anyone tell me? Does Amazon or eBay have any information to find the customer behavior? Yes. Okay. If yes, where it is? Yes, they find. That's what they went to the Amazon, they went to the eBay, and they were looking for, and they couldn't find it. Okay, do we have any info? See, I am a data engineer now working in Amazon. Okay, now I wanted to find the customer behavior because they didn't buy any option out here. So I wanted to know, and do I have any information from Amazon to do the data analysis? Because he did not do any transaction. Anyone? You have to think like this. See, whatever the action, whatever the application, whenever we are interacting with an application, there will be a log stored. There will be a logs. Log folder will be there. Logs will be stored. Okay. Each application has its own way of storing some kind of a data. And now Flipkart as Flipkart, not Flipkart, sorry, Amazon or eBay, the customer behavior will be entirely stored in the logs, log format, right? So what we have to do? Sir, it's a format of logs. Earlier, if it is a CSV file, sir, if it is a JSON file, or if it is a Parquet file, it was very easy for me to directly load it to the BigQuery and able to analyze it, sir. Right? Because CSV, JSON, Parquet, it is kind of a semi-structured data. When it is a semi-structured data, I can able to easily convert it to the structure and I able to easily analyze the data. Does BigQuery supports logs format? Log format? No, I can't load it to the this thing. How much amount of data we are talking about? How much data we are talking about? We're not talking about 1% data. It just to give you some idea. I have taken a 1%, right? Thousands, millions of the people are every day doing some kind of a interaction with the application. Millions of the people every day interacting with the applications. They are not buying out, right? So if they are not buying out, the Amazon wanted to first analyze this data and analyze their customer behavior. Other data is in the form of a logs and it is very huge. We are not talking about a small amount of data. Millions or trillions of the people throughout the world are using the Amazon. And you can think of yourself itself. If you wanted to buy some kind of a appliance, what to do? You will be researching over that appliance maybe for that next 2 days. Right. So there will be huge data for one person itself. It is stored. We are. It is. I mean, one person itself. There is a plenty of data generated, and millions, trillions of the people throughout the world they are using it. So there is a very, very huge amount of the data is generated. Very huge amount of the data. Okay. So very huge amount of the data is generated. And first challenge is, do we have two problems, sir. One is we wanted to understand the customer behavior. For that one, we need to store the data because the data is not a simple data. We need to store the data. So our first challenge as a data engineer is storage. Second challenge is what, sir? Analyzing this much of data. Okay, we need to have a robust platform which will store this data. That is our first challenge. And the next challenge is processing this data because this data is not in a CSV data. This data is not in a JSON data. And I cannot directly use the logs format to analyze the data because it's not that much, it is not that much easy format to analyze it. So we need to convert that it into a readable format. Then only we will be able to do the analysis. For that one, we need to do the data processing. So that is our second challenge. What is processing, sir? Adding some value to the data. Adding some value to the data. Now, the very first challenge is storage. Storing this much amount of the data. Storing some terabytes, petabytes of the data we are talking about. Every day, not every month, not every year. Every day we are talking about some terabytes, petabytes of the data that the Amazon has to store. Only for the logs. Okay. So where to store this data? Do you think one system can able to handle it? This. Okay, our first challenge is storage. Okay. So assume that it is 100 GB of the data. It is 100 GB of the data. Do you think the single machine can able to handle it? Do you think the single machine can able to handle it? Because it's a 100 GB of the data. Our machines are you can max to max some. No, it's not 100 GB. It's 100 TB. Okay, 100 GB is fine. So I have some 100 TB of the data, and one single machine cannot be able to handle it. So that's where we need a couple of machines. Okay, so one machine cannot be able to handle it. That's where we need a collection of machines or a couple of machines we need it so that we can able to store it. Okay, so we need a couple of machines. So we have 100 terabytes of the data. One single machine cannot be able to store it. So we need a couple of machines. So there is a nomenclature. This is what we call as a distributed system. Distributed system. Why it is? So a distributed system, they have given us some nomenclature, a collection of machines or a couple of machines. If they are connecting together, that's what they call as a distributed system. A distributed system, nothing but a multiple machines connected together. And they have also given a one more name called cluster. Let's not worry about it now. Okay, as a concept, so one single machine cannot be able to store it. So we need a distributed system where multiple machines are storing the data. For example, if it is 100 terabytes of the data, each machine is storing some 10 TB. If you have some 10 TB, or for example, four machines are there, so each machine is storing some 25 TB per machine. Okay, so that's how they will be distributing the data to the multiple machines, four machines, and they are storing the data. Okay, this is concept. But who will solve this problem? Who will manage this data distribution? Someone has to take care of this data distribution. See, you have 100 terabytes of the data, and you thought like a single machine cannot be able to store it. So as a concept, you thought that okay, couple of machines can able to store it. Okay, that's fine. And the couple of machines, you think that okay, if it is one file, one single system will be able to store it. But what you're telling, you are having some 100 terabyte, and you're telling this is machine 1, this is machine 2, this is machine 3, this is machine 4. So this 100 data has to be split and store it in multiple machines. That means data distribution. Data is distributed to the multiple machines. Okay, now the question is, who will manage this data distribution? Who will manage this data distribution, sir? Okay, yeah. So there we need some tool. Okay, let's not worry about that. Okay, who will organize this data distribution? Who will organize this data distribution? Again, one more question. So managing the data distribution, organizing the data distribution, finally, who will actually store the data? Okay, who will actually store the data? So these are the three questions that people are having it. So people know already that earlier, like if you can go back to the 10 years before, maybe in 2010s era, what the people were facing a problem is that this was a question to them. That was a stage where the big data was entering into the market, where in 2010s there will be a plenty of the data keep on generating, plenty of the applications came into the picture, people are interacting with the application every day, every now and then. There is a huge amount of the data generated at each application. They were facing a problem that they wanted because single machine cannot be able to store it, so they need a couple of machines connected together. That's what we call as a distributed system. So in a distributed system, data will be distributed to the multiple machines, but concept wise everything was good, but they were looking for some tool who will organize or who will manage this data distribution. Okay, so that's where Hadoop came into the picture. Hadoop has introduced one of the tool, that is HDFS. Okay, that is HDFS. HDFS. Hadoop has introduced one of the tool, that is one of the product from the Hadoop market itself. It is HDFS, Hadoop Distributed File System. Okay, Hadoop Distributed File System will actually manage the data distribution. Hadoop Distributed File System will actually organize this data distribution. And who will actually store the data? Hadoop. HDFS does not store the data. HDFS is a concept. HDFS is a tool. Under the hood, under the HDFS, there will be a cluster. Cluster will be having tools. Workers will be actually storing the data. Okay, so this is what it is. This is how HDFS came into the market. What is a HDFS, sir? HDFS. I'll tell you HDFS is. HDFS is nothing but a Hadoop distributed file system. Hadoop distributed file system. Hadoop distributed file system. It splits the data and distributes the data among multiple machines in a cluster. So they have, when the Hadoop was introduced, right? When the Hadoop was introduced to the market, they have come up with a name called cluster. They have come up with a name called cluster because they don't want it to call couple of machines, collection of machines, okay, collection of machines, multiple machines. They don't want it to call. So they have given us some nomenclature that is cluster. Cluster is nothing but a collection of machines. And they don't want it to call it as a machines also. They are calling it as a node. Okay, node is nothing but a machine only. Okay, so Hadoop distributed file system splits the data and distribute the data in multiple machines in a cluster. Okay, a cluster is nothing but a multiple machines, sir. A cluster will be like this. If I have to say a cluster will be like this. In a cluster, you will be having master node. People also call it as a name node, manager node. Okay, so master node, or you can also call it as a name node. You can also call it as a manager node. All these are same names. Okay, you should need not to confuse. Okay, in a master node. So this is a nomenclature. I have to say like here. Okay, so you will be having a master node, and under the master you will be having slaves. Slave, or you can also say, usually people call it as a worker node. Worker node 1, worker node 2, worker node 3. You can think of like it is a machine of 4 machines. It's a cluster of 4 machines. Okay, it's a cluster of 4 machines. Now you have the master is connected to the worker 1. Master is connected to the worker 2. Master is connected to the worker 3. Okay, so this diagram, what we call as a cluster. This is nothing but your cluster. Okay, this is your cluster, sir. A cluster is a collection of machines, nothing but a collection of nodes. Here, how many machines we have, sir? Can anyone tell me how many machines we have? How many, sorry? 4 machines. So this cluster is a collection of 4 machines. So out of this one, it's actually cluster means a collection of machines. Cluster is a 4 machines. But HDFS concept is that Hadoop's concept is that out of 4 machines, one is acting as a master node. One is acting as a master node, and all other three are acting as a worker nodes. Okay, when you're working in a project, you will be having a manager, and under them there will be a developers, developer 1, developer 2, developer 3. Now tell me, who will be actually doing the project work? Who will be completing the task in a company? Developers. Likewise, when you actually wanted to store some data, if you give some 100 data, so 100 GB terabyte to the this particular cluster, the master does not store the data. Workers are the ones actually storing the data. And now, what will be the manager doing in the project? What the manager do in the project, sir? Correct. So, if he gets the data from some client and he will be distributing the task to the different developers, and he will be tracking the task. He will be tracking the task, what the developer doing, whether they are able to complete it or not, and they are meeting the deadlines, and all the things are the manager will be taking care in the project. Likewise, when the HDFS got the data from some client, assuming that some 100 terabytes of the data, so manager node will be actually taking care of this distribution, and once the data is distributed, it will be tracking how much data, because see, if I give some kind of a 100 GB of the data, some 100 GB of the data, if I give, I expect the 100 GB output. Or if you've done some kind of a processing, that's also fine. Okay, that's also fine. And you give me some 10 GB is a wasted, so you give me 90 GB. But I expect 90 GB as a one single file. I don't expect to, okay, this guy give me 30 GB, this guy give me 30 GB, this guy give me 30 GB. No, no, no. I don't expect that, because I, as a person, given 100 GB as a data to the HDFS, I expect the entire GB as a one file to me, so that I can able to use it for the analysis purpose. Okay. So that's what it is. So that kind of a things also we need to take care of it. Now, what is HDFS, sir? You can look at it here. HDFS, Hadoop Distributed File System. It split the data, splitting the data, right? It splits the data. So you give 100 GB, so that splitting will be done. For example, this is something like 30, 35, 35. It splits the data and distribute it to the multiple machine. Here it is, here it is, and here it is. So it will distribute it to the multiple machine. This is the concept of HDFS, sir. This is the backend concept of HDFS. Okay, with the help of what it will be doing, sir? With the help of the cluster only it will be doing. HDFS is a concept, HDFS is a tool. Cluster is the one, if you do not have a cluster, HDFS cannot be able to do it. Okay, so that's what it is. So HDFS will split and distribute the data to the multiple machines in a cluster. Okay, a cluster is nothing but a collection of nodes. In a nodes, you will be having one master node. Categories of nodes are master node and worker nodes. Master node can also be called as a name node, manager node. Likewise, worker node. Worker node can also be called as a slave node, also called as a data node, where the actual data is stored. Okay, so this is what is the concept of machines. Categories. So nomenclature, tomorrow if someone says, okay, some companies use master node and worker node concept. Some companies says name node and slave node, name node and data node, manager node and slave node. So if they are using the different nomenclature, you shouldn't confuse. Okay, now the question is HDFS is solve the problem or not? We have a problem of storage. This is our problem. Okay, this is our problem. HDFS that storage problem solved by the HDFS or not? Right. Because whatever the data you give it, I'll increase the one more machine. See, I'll increase the number of machines. For example, if it is 1000 dB, I'll increase 10 more machines. That's it, right? So HDFS will be able to store any amount of data irrespective of the amount of the data. So it will be able to store the data, and it will be able to manage the data and organize the data. So that's the concept of HDFS. Now the challenge was fixed by the HDFS, Hadoop. Hadoop distributed file system has fixed our storage issue. What is our issue, sir? Storage. We are unable to store the data, and now we are able to store the data. Any amount of data, we are able to store it. Right? So that's perfect. Next thing is, sir, storage is fine, but that's not our end requirement. Because if I wanted to do the analysis, I need to first store this data, logs. I need to first store this data. Now I have stored this data. We need to process the data. Nothing but a computation. The next challenge is computation. Computation, nothing but a processing. Okay, nothing but a processing. Okay, so what we are going to do, sir, here? So processing is also very simple. Say we have a very large amount of the data. That data is already have. That data is already there in the cluster. That data is already there in the cluster. Okay, so you have a very large amount of the data and that you wanted to process this data. And that data is already stored in the worker nodes. What you have to do, sir? What you have to do, sir, you need to have some kind of a processing framework which will do the data processing as per our requirement, because I wanted to process this data may be having some duplicates, this data may be having some null values, this data may be a bad data, this may be some data, may be a bad records of the data may be having it. Okay, we need to have some kind of a processing framework for processing this data, or we need some programming model or a processing framework which will be doing this large data processing. That's where Hadoop has introduced one more tool, that is what's that? MapReduce. Okay, so MapReduce was introduced to the market for doing the data processing. It's a programming model. It's a processing framework used for the used for the distributed computation or large data processing. Okay, what this MapReduce will do? So this is what it will do, sir. MapReduce actually works in the map and reduce manner. For example, give me 1 minute, guys. Give me 1 minute. I'll be back. Sorry, guys. So I'm back. Yeah. See, MapReduce. Let me take one simple data and try to explain it to you guys. Assume that I have a data here, the temperatures. Okay. Assume that I have a temperatures data. Okay. So the temperatures data will be like this. Okay. Hyderabad from 40, 45. Delhi from 46. Chennai from 47. Bangalore 37. And Indore 38, Mumbai 44, 42. Okay, so this is how you have some temperatures data. Okay, so you have assume that you have a sample data. This is your sample data. Okay, this is your sample data. Okay, the user wanted to find the analysis they wanted to do is that the maximum temperature. They wanted to find maximum temperature, sir. That's the requirement, max temperature. Tell me, sir, what is the maximum temperature? So the user wanted to find the maximum temperature because you have a sample data here. So only some 10 records are there, sir. It's easy for me to find the maximum temperature. But tomorrow you will be getting a large amount of the data. But how do you do that? So you don't want it to manually look at it, but because now it is a single 6 records only, sir. I compare it all the records and I say that the 47 is something. Chennai is having a maximum temperature. The city is the Chennai is having a maximum temperature of 47. You say it because you have only 6 records here. But tomorrow you will be having some crores of the data where you have to find the maximum temperature. Manually looking at it and trying to get the maximum temperature is very hard. So now what will happen is that map reduce. Okay, so you already know that. So assume that you have these machines, right? So when you give this 100 GB of the data, some amount of the data will be stored here, some amount here, some amount here. So assume that you have this data is stored in machine 1, this data is stored in machine 2, this data is stored in machine 3. Okay, so this is how the machine 1 is storing this amount of data. This is machine 1, machine 2, machine 3. So 3 machines are storing some. This is what the HDFS will do, right? HDFS will distribute the data and split the data and distribute the data to the multiple machines. Now it is having 6 records. You can think of like 6 crore data. So 2 crore data here, 2 crore data here, 2 crore data here. Now what the MapReduce will do? MapReduce is a programming model. It's a processing framework. So here is machine 1, machine 2, machine 3. And MapReduce is just nothing but a code. Here you have a map task. Okay, let me try mentioning here like this. MapReduce is nothing but a map task and reduce task. So you have 2 tasks here. One is map task, one more is reduce task. Okay, what the map task? Map task and reduce task are nothing but a code, sir. You need not to worry about it. It is nothing but a code. The code was mentioned in the Java because map reduce totally process the data with help of the Java only. Okay, the entire code is mentioned in the Java. So map code as well as reduce code. Now map code, what it will do? Sir, the code will be moved, the data will not be moved. See, what is the problem with the other frameworks is that other than the HDFS or other than the Hadoop frameworks is that, so the data will be distributed to the processing layer. Okay, so you might have think that there will be a storage layer, there will be a processing layer. But here, so what was the problem with other systems is that they have their own processing layer, storage layer. There will be a network which will be moving the data between these two things. You can think of like this is a storage layer. I might have told you this thing, storage layer, processing layer. So you store this 100 GB of the data here. If I have to move this 100 GB to the processing layer over the network, it takes a lot of time. It takes a lot of time. Okay, so that's the reason Hadoop does not follow this method, because Hadoop just because this processing framework, it is just a code. This code is nothing but a hardly 1 MB or 10 MB hardly. So the code will be moved to the storage layer for the processing because it's a cluster. So what will happen is that out of this cluster, worker node, master node, worker node 1, node 2, node 3 are actually installed with the prerequisite of the HDFS as well as MapReduce. Okay, so they have comes up with the pre-installed MapReduce programming framework as well as the HDFS for storage of the data. So whenever you give some 100 GB of data, master node will be distributing the data to the multiple machines. And whenever you send this Java code to this thing, this thing, this thing. So these are the 3 different machines and you send the map task. So this is like you send the code here. Okay, so you can think of a map. Okay, you can think of a map. So this is map 1, map 2, and map 3. So the same code. The code is same thing, sir. Maximum temperature I wanted to find. Now tell me, sir. If I find the map, this particular task, map task found that, what is the maximum temperature here? 46. Here the maximum temperature is 47. Here the maximum temperature is 42. Now tell me, these are the final results? These are the final results? No, because this machine have its own maximum temperature. This machine will have its own maximum temperature. This machine will have its own maximum temperature. Okay, we don't want it to take that because map task will give you the maximum temperature in this particular machine, but that's not the global maximum temperature. Okay, now that's where the reduced tasks come into the picture. It's again the same code. It's again the same code. Okay, the code will not change. The code is same. Now, whenever the map task was running, it was related to the single machine. Now, whenever the reduced task was running, it was related to the all the machines. Now, whatever the result of the map task was there, right? It will be given to that will be the input to the reduced task. Now the reduced task will come into the picture. This is your reduced task. And the input is 46, 47, 42. The code is same thing. Map code as well as the reduced code is same thing. Map code was to get the maximum temperature. Here also the reduced task is to get the maximum temperature. Now 46, 47, 42, which is maximum, sir? 47 is maximum. Okay, so this is how you are going to get the data. Okay, so this is how the map task and reduce task will work in the map reduce. Okay, so you wanted to find the maximum temperature, and this is your maximum temperature. And this code was written in Java. This entire code, map code and the reduce code was mentioned in the Java. What was the problem with the Java? What was the problem with the Java? People are unable to process the code with the Java. People are not able to process the code with Java. People are finding it very difficulty understanding the Java code because processing the Java code, processing the data with the Java is very hard. People are facing a lot of problems. So that's the reason MapReduce was, plenty of the people don't want to use the MapReduce because they needed Java expertise to work with the MapReduce. They need to create a map task and reduce task, which is there in the Java only because Java is a good language. It's very heavily used. But when it comes to the data processing, it's creating a lot of difficulties. The challenges with the challenges of using the Java with the data processing is very high. Plenty of the challenges it is creating, and it's not that much simple language as well. So that's where people are unable to process the Java. And one more problem is this is one problem. The problem with the MapReduce we are talking about. MapReduce can able to handle the data. MapReduce can able to process your data. That's well and good. So MapReduce will able to process your data. This is well and good. But the problem with the MapReduce is that MapReduce code was written in Java. So people are unable to write this language. That's one of the problem. One more problem is MapReduce can only take care of the batch data processing. The second problem is only batch data processing. It cannot do the streaming data processing. This was the second problem. And because you only give the data in the form of a batches, you can't give a streaming data. Streaming data cannot be inserted to the Hadoop. This MapReduce. It cannot do the streaming data processing with the MapReduce. So that's one more problem. The third problem is whenever you are working here, so you see here worker node 2, worker node 3. Whenever you are storing this data is actually stored in the disk. Okay, so it's a disk oriented. It's a disk oriented, means the data will be stored in the disk. You already know. So why do we buy a phone of 8 GB, 16 GB, 24 GB? It's a RAM. GB is nothing. That 24 GB, 16 GB is a RAM. When the RAM is very high, when the RAM is very good, the processing speed will be very good. But MapReduce actually stores the data in the disk. It does not bother about the RAM. It does not keep the data in the RAM. Okay. So when you are not dealing with the RAM, when you are dealing with the disk, loading the data from the disk is very hard for the processing framework. So that's where this is a one more challenge. So what will this particular MapReduce will do is that whenever it is processing, this is what it will do. So you have a disk, that is fine. You are storing the data on the disk. Machine one, you take one machine. So that machine is storing the data in the disk. So you done some transformation one, and it is again storing it to the disk. You do the some transformation two, again storing it in the disk. You do the one more transformation, again you are storing it to the disk. You do the transformation four, again you are storing it to the disk. Okay, finally writing it to the output, some other layer. So see here, you are again reading the data from the disk, writing it to the disk, again reading the data from the disk. Is again, see, whenever you are doing some kind of activity with the disk, right, disk will be a little bit slow compared to the RAM. So this was a one more problem that the MapReduce was with the MapReduce people are facing it. So that's where, sir, you told like MapReduce having a plenty of challenges. MapReduce Java is a problem. Batch data processing it only allows batch data processing, and it is only a disk oriented tool. Now, sir, can you tell me any tool which will be very easy and uh, we can able to do the data processing very simply? So that's where the Spark came into the picture. Spark took over the market of MapReduce, and it was giving you, it was fixing all the challenges that the MapReduce actually created. And there are companies using the MapReduce, and there are companies, mostly 90+% of the companies are using the Spark only. I'll tell you why. Spark was introduced. Okay, when it comes to this one, I'll tell you. So you read the data from the disk one time. Okay, transformation one, you write it to the RAM. Again, two, you write it to the RAM. RAM is nothing but a random access memory. It's your processing. Again, RAM. Again, RAM. Finally, to the output. Finally, to the output or to the disk, whatever it is. Okay, so all the intermediate steps are doing in the RAM. When you are doing that intermediate steps in the RAM is very faster, because when you put some amount of data over the memory, doing the processing is very faster. So that's the reason Spark was very famous. This is one method. This is one challenge was fixed by the Spark. And one more is, like MapReduce does not provide you the client support. MapReduce is not providing you the client support. It only providing you the Java. But the Spark actually provides you. Spark actually provides you the client support. If you wanted to write your code in Python, Scala, Java, or okay. So this is what. So Spark provides you the client support. Spark and MapReduce both are same. Spark was developed from the MapReduce only. Spark was referenced from the MapReduce only. When it was developing, from where the Spark was developed? Spark was developed from the MapReduce only by fixing the problems. And Spark is providing you client library support. Python, Scala, Java, R. People are able to write these languages very easily, and they are able to process the data very simply. This challenge, language challenge also fixed. One more thing, final thing. Spark supports both batch data processing, stream data processing. Spark supports also. It supports batch data processing and stream data processing. This challenge also fixed. Okay, that's how Spark took over the market, and Spark is heavily used nowadays. Okay, so this is how we have storage challenges fixed, processing challenges fixed, and Spark entered into the market. And Spark also having a plenty of Spark will also do the data processing. However you wanted to do the data processing, you can able to do it. Which language you wanted to do it, you can able to do it. And it supports batch plus streaming, and it also do the data processing very faster. People say 100 times faster than the Hadoop. Map 100 times faster than the map reduce, sorry. So when you do the some kind of a data processing with the map reduce, if it is taking 100 minutes, with the Spark it only takes 1 minute. That's how very fast a tool the Spark is. Okay, so this is what is related to the Spark and Hadoop environment. Now the problem is now the problem is Spark map reduce HDFS needs what, sir, to process the data? Spark or MapReduce or HDFS, all of these things, what they need to do the data processing or to do the data storage. What it needs, sir. Right. They need cluster to do the data processing. They need cluster to do the data storage. Right. So if you do not have a cluster, they cannot be able to do it. So cluster is the one actually storing the data. Cluster is the one actually we install our MapReduce or a Spark on top of the worker nodes and doing the data processing. But the problem is, what is the problem, sir? People are unable to manage this cluster because they have to create four machines, or if tomorrow it is 10 machines, 15 machines, they have to manually create these machines and connect it to it and make it available over the network, and all of those things they have to do it. And creating the clusters is not that easy. Creating maintenance management as well as configuration, network, storage, backup, all of these things for the cluster is not that easy. So that's where people are looking for a solution. People are looking for some kind of a managed services. So that's where you have DataProc, Databricks, EMR came into the picture. DataProc, Databricks, EMR, all these are the managed instances, managed services for this HDFS or Spark or Hadoop environment. You can think of like this. DataProc, Databricks, Elastic EMR are the managed instance for Spark and Hadoop jobs. Okay, if you are managing your Spark job internally, locally, if you are managing your Hadoop job locally via managing own cluster and all of those things, if you don't want it to do all of those things, you can go for DataProc. DataProc comes up with a pre-installed HDFS map reduce as well as Spark. You don't need to manually install it. You don't need to you don't need to create a cluster of machines. You don't need to actually manage the network. You don't need to take care of the storage. You don't need to take care of the backup. All the things will be taken care by the DataProc, Databricks, EMR, because these are the managed services for Hadoop and Spark. The main purpose of the DataProc is to run the Hadoop jobs and Spark jobs seamlessly without needing to manage the infrastructure. So that's the reason DataProc, Databricks, EMR become very famous. Okay, so this is what we are going to learn from tomorrow. That is DataProc. So from here, I'm going to stop the session. So if you guys have any questions, you can ask. Any questions, anyone? Yes, Nagaraj. You can think of Spark is it's an entire entity. You can think of, okay, it's a replacement of MapReduce. You can think of, okay, but Spark does not have its own storage. Spark will always depend on the HDFS. Workers is nothing but a file storage systems, file systems. You can it's like a one virtual machine. Virtual machine will have its own storage, like our laptop. Think like our laptop. Okay, so our laptop will have a disk, right? There we are storing the data. Likewise, one virtual machine will have its own disk storage. Okay, there it will be stored. No, no, no. Normally file systems. Okay, yeah, it's object storage you can think of, because we are not. This data is not structured data. Okay, so you are wanted some kind of a storage solution where you are any amount of data you wanted to store. You do not know whether it is structured or whether it is object or whether it is some dot CSV files. You do not know that. Okay, you just wanted to store it there. Okay, that's where you are going to store it to. You have some file that is CSV. You have some file logs. You're gonna copying it and keeping it in a D drive. So that's what it is. Similarly, like that. Correct. Correct. Any amount of data, any kind of a data, any format. Yes. No, no, no. Usually it is not for log files, but to give you that idea, I have told you. If I tell you that it is a CSV file, sir, we already have a CSV file, we can able to load it to that. So my point of saying is that you have a very large amount of the data, and you need some kind of a pre-processing. Okay, you need some kind of a pre-processing. If it is assumed that you have a CSV file, and the CSV file what you get is may not be in a cleaned format. Okay, you need to do that data processing before loading it to the analysis purpose. So for that purpose you need a data processing system, so that you will be able to process the data here. Some process, some value addition you are going to do it here. So then you are going to analyze it. If you when you are not doing the data processing but you are directly loading it to the BigQuery, that data you are loading it, right, that may be having some bad records, data may be having to some duplicates. You need to actually pre-process it before you sending it. So that's the reason DataProc and all of these things, Hadoop and Spark are important. And when you it's not only for like that. So tomorrow you wanted to have some tool which do a big data analytics. You wanted to do some kind of a robust data processing. Not even a single tool available over the world other than Spark, which provides you that much capabilities. Okay, so Spark is very very widely used, very famous. You do not have any tool so far in the world which actually competes with the Spark when it comes to the data processing. That much faster the Spark is. Okay, so mainly for the data processing. Correct. For HDFS for storage. So nowadays people are don't wanted to use the HDFS also. People don't want to use the HDFS. They are actually using the data lakes. Like you have a GCS. GCS works that similar way, and you have a. I will tell you tomorrow. This is if I tell you, it will be difficult to understand. Tomorrow I will tell you. I will just, give you the high level information tomorrow so that you will get a lot of information. Yeah. Any other questions, guys? Are we good? Okay. Okay, guys, we will see tomorrow. Just I'm gonna give you some more idea about all of these things, and we're gonna be starting the PySpark, how to create a cluster, and after that we're gonna be working with the PySpark. Stay tuned, don't miss. Bye bye, guys. Have a great day.